Welcome to Ask and Learn.
In this problem, we have two blocks, A and B, and we want to find the velocity of block A, which we'll call VA, when it moves down the plane at a distance of 5 feet, and we'll call that SA. And of course, we're given the weight of block A, and that's 60 pounds, and we can convert that to mass by divided by 32.2 feet per second, so it's a second squared. So our mass A is 1.86 kilograms. The weight of block B is 10 pounds, and we can convert that again. So we get MB is equal to 0.31 kilograms. So since we're dealing with a distance of 5 feet and we're dealing with forces on the blocks, and we also have speed involved, we can use the work energy principle to find the velocity VA. So the way this works is we're given the equation kinetic energy initial of the event plus the work being done is equal to the final kinetic energy. And since the blocks are at rest when it begins, then the initial kinetic energy is 0. And so we're left with the work being done is equal to the final kinetic energy. We can simplify that. So work being done is equal to 1/2 MA VA squared plus 1/2 MB VB squared. So now let's look at the equation for work. So we want to look at the work being done by both block A and block B. So we're given WA, the force of block A, times the distance S, in this case SA, minus weight of block B, the force on block B, times its distance that it travels, SB. But block A is at an angle, and so we can't just say weight A or the force times the distance because it's at an angle. So you want to find the force at that angle. And so we're given a triangle like this, 5, 4 on the bottom, 3 on the side. So we want to find the force in this x direction where this 4 is at. So we need to incorporate this 3 and 5. So it's this equation becomes weight with block A times the ratio of 3/5 times SA minus WB times SB. Okay, now we can plug that back in to our equation, this one. So now we have WA 3/5 times SA minus WB SB is equal to 1/2. This stays the same, MA VA squared plus 1/2 MB VB squared. So looking at this equation we know weight A, we know SA, the distance that's given to us, we know weight B, we know MA, we know and B. But what we don't know is the distance block B travels and the speed of block B. So the way to do that is we can relate the distance SA with the distance SB, and we can relate velocity of block A, and the velocity of block B. So we can say the distance that block A travels plus the difference of distance A minus distance B will equal 0. So then we have 2 SA minus SB equals to 0. Now we can solve for SB. So we have SB is equal to 2 SA. And then we can do the similar thing with the velocities. So we have VB is equal to 2 VA. So now we have an equation for SB and VB. So now we can plug in our values. So we have 60 for the weight times 3/5 times 5 the distance minus 10 for the weight of block B. And now SB is 2 SA, so we have 2 times 5 is equal to 1/2 MA, which is 1.86 times VA squared. VA is what we're looking for, plus 1/2 0.31 times, and then VB becomes 2 VA, so it's 2 VA squared. Now we can simplify this a little bit. So on the left side we have 180 minus 100 is equal to 0.93 VA squared plus 0.62 VA squared. So then we have 80 is equal to 1.55 VA squared. So now it's just a matter of solving for VA, which is what we're looking for, the velocity of block A. So we have 80 divided by 1.55. And to get rid of the square, we take the square root of both sides. So VA, the velocity of block A, is 7.18 feet per second.